Next, we're going to take a look at solving trig equations by factoring, but they get a little bit more complicated in this lesson. So we'll take a look at our first one, and we'll also learn how to solve them completely, talking about the multiple answers we can get on the unit circle, and remembering the fact that every time you go around the unit circle, you come back to the same place. So we'll start by noticing that we have two different functions here, both sine and cosine. However, we have a common function in both our terms. They both have a cosine x. So we're going to start by factoring out that cosine x, leaving us with 2 sine x on our first function, minus 1 from that second one, equals 0. And once we have it factored, we're going to set each piece equal to 0. So we have cosine x equals 0, and 2 sine x minus 1 equals 0. Where is cosine equal to 0 on the unit circle? So remember, cosine is your x-coordinate, and the x-coordinate is 0 on the y-axis. So we have at pi over 2 in radians and at 3 pi over 2. So to solve completely, I'm going to sketch the unit circle real quickly here. So when we're solving completely, we need to think about the fact that if we rotate pi over 2 radians, and then we rotate from there another 2 pi, we get back where we started. So our complete answers will be x equals pi over 2 plus 2 pi n. What that means is for any multiple of 2 pi in either direction, positive or negative, will land back at the same place, and the cosine value will be 0 there as well. So we'll do the same thing for our other answer, x equals 3 pi over 2 plus 2 pi n. Looking at our sine function, adding 1 to both sides, and then dividing by 2, we're looking for where the sine of x equals 1/2. Remember, the sine function goes in order 1, 2, 3. So here at pi over 6, sine is 1/2. So we'll do the same thing, pi over 6 plus 2 pi n gives us that general solution, or solving completely, but the sign is also positive in the second quadrant at 5 pi over 6. So we also have 5 pi over 6 plus 2 pi n for our complete solution to that one. Again, we have those two functions, so we're going to factor out that tangent, leaving us with the square root of 2 times cosine x minus 1 equals 0. So setting each piece equal to 0, we're looking for where tangent is 0. And we're also looking for where the square root of 2 cosine x minus 1 equals 0. Solving for our tangent function, remember tangent is sine over cosine. So when we sketch our unit circle here, sine over cosine. So we're really looking for where sine is 0. Since sine is our y-coordinate, sine will be 0 on the x-axis. So in degrees, at 0 degrees and 180 degrees. Solving our second equation by adding 1 to both sides and then dividing by the square root of 2. We're looking for where cosine is 1 over root 2, but if we rationalize that, we'll hopefully recognize that as root 2 over 2, and that's the one where sine and cosine are equal, so that occurs at pi over 4 in radians. We're in degrees this time, so at 45 degrees. And cosine is also positive in the fourth quadrant because we're looking at that x-coordinate, so cosine's positive in the first and fourth quadrant, so that one, our other answer will be 315 degrees. And again, for our solving completely, a full rotation in degrees is 360 degrees, so we have that plus 360 n for both of those as well. One last one, now we're going to take a look at what happens when we have Pythagorean identity. So we still have two different functions, but this time we don't have a GCF, so we can't factor anything out. But secant and tangent are related by that Pythagorean identity, so we're going to replace secant squared with 1 plus tangent squared. And then we can do our t-chart factoring after we reorganize this. So I'm going to subtract that 4 from both sides and reorganize so it's in standard form. So I'm going to start with my tangent squared, subtracting 2 tangent x, and then I'm going to put that plus 1 on the end, but when I subtract 4, I'm going to get a minus 3. So we're looking for what numbers multiply to negative 3 and add to negative 2, and that would be negative 3 and positive 1. So setting each of these equal to 0, we're looking for where tangent x minus 3 equals 0 and where tangent x plus 1 equals 0. So the first one is going to be a non-unit circle value, and the second one is on the unit circle. So let's start with the unit circle one. We're looking for where tangent is negative 1. Tangent is 1 or negative 1 when the sine and the cosine are equal to each other, and hopefully you guys have that memorized at this point. That occurs at, in radians, pi over 4. So that's where tangent would be positive 1. Tangent is negative when sine and cosine have different values. So we're looking at 3 pi over 4 in the second quadrant. In the third quadrant, sine and cosine are both negative, so tangent would be positive. And then over in the fourth quadrant, tangent would be negative again at 7 pi over 4. So our two answers for this one, solving completely, would be 3 pi over 4. All right, so now let's take a look at the one where we're going to have to use our calculator. Since 3 is not an exact tangent value, we're going to take the tangent inverse of 3, and we were asked for our answer in radians, so we'll get a decimal approximation on this one. So for our first answer, I got about 1.249. I just realized we need to talk about the solution for the last one, because tangent does not have a period of 2 pi like sine and cosine does. Looking at the unit circle, tangent repeats every half a rotation. Tangent has a period of pi. So for tangent, we really only need the first answer, because if we rewrite this as plus pi n, that will give us the 7 pi over 4 after a 1 pi rotation. So we don't need that second solution. So for here, again, we're just going to put plus pi n, and that will give us all of the solutions with that half a rotation around the unit circle. So we're going to go back and fix this answer as well. We can fix this one. We don't need this answer at all. And if we simply change this to 180 degrees, that will cover all of the possibilities for our tangent function, where tangent would be equal to 0. Sorry about that. I forgot about that special period for tangent. All right, and if that didn't mess you up completely, this one at least doesn't have the tangent function, so hopefully you can get this one solved based on what we talked about, and we will clarify anything else that needs to be clarified in class.